Καλησπέρα σας, welcome. Σας ευχαριστούμε όλους που βρίσκεστε εδώ. Γεια σας. Μπορείτε παρακαλώ να μου επιβεβαιώσετε ότι όλοι μας ακούτε?
Χαίρετε, ναι,
Καλησπέρα.
εγώ ακούω μια χαρά. Χαίρετε.
Ναι,
Γεια σας.
Καλησπέρα,
Γεια
σας
σας.
ακούμε.
Γεια
Σας
σας.
ευχαριστούμε πάρα πολύ για την ανταπόκριση. Σας ευχαριστούμε όλους που βρίσκεστε εδώ σήμερα. Καταρχάς, κάτι που θέλουμε να ρωτήσουμε είναι ότι καταλαβαίνετε όλοι ελληνικά ή θέλετε να προχωρήσουμε με το webinar στην αγγλική γλώσσα? Does everybody understand Greek, or would you like to proceed with this webinar in the English language?
If there is anyone in the audience who is a non-Greek speaker, please raise your hand.
Well, we have one in the chat section. Joro, if I can pronounce it correctly.
Okay.
Well,
I can see we have another hand. So even for one person, it's fair for everybody to have this recorded in English so that everybody can follow along.
so let's proceed, Stefane. Thank you so much for joining us today for this exciting webinar organized by New Horizons on AI and machine learning. Our webinar, as you already know, is Certified Artificial Intelligence Practitioner. I'm thrilled to have you all here, and I can't wait to dive in. But first, let me share a few words about New Horizons. Well, New Horizons is a global leader in the provisions of information technology and business process training. For over 40 years, we've trained more than 30 million people around the world, helping them turn IT learning into real business value. And as a leader in IT skills, project management, and leadership development training, we're the official training partner for top vendors like Microsoft, CompTIA, Certnexus, Cisco, and VMware. In a few words, we provide companies and people with IT and career development courses. For more information, you can check our website, and let's dive in. Stefane?
Sure. Thank you for the introduction. First of all, can everybody see me? You should be able to see me
Yes.
through the camera. And now I just shared my screen with the presentation slides. Can everybody see them?
Yes, yes.
Yes. Okay.
Yeah, we can.
So let's start. As Kali mentioned, we will be covering at a high level topics related to artificial intelligence and machine learning inside of the Certified AI Practitioner certification and upcoming course that New Horizons is organizing in coordination with Certnexus. So the topic of today's webinar is let AI decide, would you survive the Titanic? So we wanted to give it a little special touch and give you a real case study that would enlighten the way that AI can be used into solving real life problems. So before we dive into the actual contents of this presentation, let me tell you a few things about myself. My name is Stefanos Evangelou. I'm a cloud architect, AI practitioner, and certified trainer. So I mostly work from the infrastructure and operations side of things, mixing cloud knowledge with AI. And I'm also a certified trainer in Microsoft, a Microsoft certified trainer, a CompTIA technical trainer, as well as a Certnexus authorized instructor. If you would like to see more about my profile, I have a personal website where I blog about topics related on AI and mostly cloud. Let me tell you a few things about the webinar itself so that everybody's on the same page. We estimated this webinar to have about 1 hour of length, and we will reserve some time for a Q&A session at the end. So if there are any questions which come up during the webinar, please feel free to use the Q&A session inside Microsoft Teams to type in your question, and we'll gather everything at the end and time permitting, we will be able to cover, if not all of them, most of them, hopefully. It's very important that you remain muted throughout the session so that we don't miss any time, with background noise, and we have a clear, crispy sound. And letting you know also that we will have a video recording of the webinar, which we will make available to you at the end of the webinar. Now, what are we going to cover at high level so that everybody's on board? The agenda is, first of all, we'll do a theoretical introduction into the machine learning, ML, and artificial intelligence, AI concepts. And then we will briefly discuss some of the most important problem-solving scenarios that we come up with when we deal with AI cases. And then, following the theoretical part, we will dive in to a demo that I have prepared, which actually runs on a local virtual machine that I have created. And it utilizes historical data from the passengers of the historic Titanic. And based on this data, we will actually train an AI model to learn from the data and understand how the data that we get from the passengers list correlate with each other and with the probability that any single passenger would survive or not. And then, to make things even more fun, I would like to ask some volunteers to give us their first and last name and some hypothetical data to fill into a new file that we will feed the model with. And then the model will come back to us and give us the probability that each and every one of you would survive or not, if you were to be passengers of the historic Titanic. And at the end of the webinar, we will give you a brief introduction into the actual Certnexus Certified AI Practitioner CAIP-210 certification, which is about to commence right after the webinar. We have planned for a course on the same topic, which will lead all participants to gaining the vendor-neutral certification of Certnexus. And at the very end, as I mentioned, we'll have a Q&A. So without further ado, let's proceed with the introduction to ML and AI concepts. I have created a so-called Venn diagram. A Venn diagram is a diagram comprising circles which actually categorize concepts into knowledge areas. So for each area, we have a subject matter expert, somebody who's an expert in their field, and we need to classify the concepts of machine learning and AI and see how they relate to each other. So we start by looking at the big circle, which is artificial intelligence. Everybody's inside there. Inside that circle is what interests us in the framework of this webinar. Inside the AI, we have machine learning. So machine learning is a crucial part of AI. When we talk about AI, obviously we mean that we give the possibility to algorithms and computing systems to work with humans, or in some cases substitute humans' intelligence, and provide similar capabilities which are related to cognitive abilities, like, for example, being able to see an image and recognize patterns from it. Now, in order to be able to provide this artificial intelligence via specialized algorithms and computing systems, we need to have some sort of machine learning. What is machine learning? Is the process of feeding data into a computing system, an algorithm, processing this data, and be able to extract associations between data at large scale. So when this data goes very high in terms of scale, the machine and the machine learning algorithm is able to understand associations between the data. And then after the training has been completed, then the machine can come back and give us its estimations or even make decisions based on input that we give it for the first time, based on data that it has not seen during its training. So that's the whole assumption of machine learning. In order to implement machine learning and be able to realize artificial intelligence systems, in turn, we need to have one or more algorithms, machine learning algorithms and systems, which would basically manipulate the data and extract the knowledge from them. One special type of machine learning algorithms, which is, as you can see, a subcategory of machine learning, is what we call deep learning, DL. This refers to what is called a neural network. So a neural network can be thought of as an artificial network of neurons, which simulates the way that the human brain works. So similarly to having neurons and synapses between the neurons, we can create a computing system implemented into hardware and software, which basically simulates the way that a neuron network works. And this constitutes what is called the deep learning. We call it deep because it's very complex and it can do very deep calculations and have a deep understanding of the data and the associations between them. It is therefore this reason why the most complex systems nowadays are being tackled with deep learning systems. And now, aside the big circle of artificial intelligence, we also do have two other circles, namely the data science circle and some other principles called the hybrid infrastructure, cybersecurity, and software development. These are actually supplementing factors and areas, scientific areas, which work alongside AI and provide the expertise that is needed to actually implement an AI system end-to-end. Data science refers to manipulating data and preparing them in such a way that they're interpretable and are able to be manipulated in the most efficient way by the machine learning systems. And the other principles that we mentioned, being hybrid infrastructure, cybersecurity, software development, they actually refer to IT professionals which provide their knowledge into making AI a reality into practical terms, because the AI journey doesn't end when we have already trained a machine learning algorithm and that algorithm is able to make decisions. In order for it to be practically useful in production environments and data centers, to be able to offer services to humanity, it must be put into production in what is called a pipeline. The pipeline takes all operational aspects into account, including cybersecurity and the cloud infrastructure required to run such workloads. So let's move on and see what a pipeline looks like. A pipeline, from a technical point of view, is a series of procedures encompassing hardware and software systems which work together in a workflow style, starting from the left to the right, from the collection of data that we need from the machine learning models to the final deployment into a data center, so that, for example, software developers are able to call an AI model via an application programming interface API. It takes a lot of steps. So all these steps are included in the machine learning standard pipeline, which is also referred to as MLOps, ML operations. For any one of you in this audience who is a developer, you well know that we have the term DevOps, which combines the word development, software development, and operations. Something similar applies to the word MLOps, so it's operations for machine learning. So let's see each and every phase that we can see in our pipeline, what exactly it is. The first step is the collection of data. So we collect data in what is called a data set. This data can be collected in an automated or manual fashion, and it usually comprises thousands, if not millions, of records. You can think of data being in the format of an Excel file, of a CSV file, of an SQL database, and there are many, many others. So the moment that we collect the data using some sort of automation and software, we start to clean and prepare the data. That means that we may need to delete data that is very well out of the scope of the values that we're expecting. These are called outliers. Or we may even need to delete entire rows or columns of data if they seem to be irrelevant, or even fill in the missing values that we have, or do more preparation on the data to prepare it for the pre-processing. The next stage is called pre-processing and basically refers to actually manipulating the rows and the columns and making them readable for an ML algorithm. What that means is, for example, if we have data which is not in numerical format, for example, a word, a sentence, what we call a string, we may need to encode this type of data into numerical form so that the ML algorithm can manipulate it. All these kinds of pre-processing is called is also known as feature engineering. And by the word feature, we refer to each and every column that we have inside a dataset. So after we have done all the data preparation, now our data is ready to be fed into the model, the ML model, so that the model understands from the data, is trained from the data, and is able to then make predictions or make decisions from new data. We start the training by feeding in these data sets, and we run a lot of iterations for the learning. When the learning completes, we do an additional layer of evaluation and tuning for the model, which includes mostly running software methods, algorithmic methods, which basically fine-tune external parameters, which are parameters which are not intrinsic to the AI algorithm, but are external parameters. And so we do a lot of iterations in an attempt to optimize the values of these parameters so that our final ML model is as efficient as possible. And finally, when everything is completed, we go to the deployment phase where we take into account the cybersecurity issues, the infrastructure issues. Where will our models be running on? Is it going to be local infrastructure? Is it going to be cloud? Or is it going to be hybrid? And after the deployment has been completed, then the external users or developers are able to call these production AI models by using certain procedures. Now that we have seen the concepts and the ML pipeline, let's talk about a very practical question, which is the why. Every time before we embark on learning anything new, I think the most important question to answer for ourselves is, why do we do what we do? What's the reason behind it? What is going to be our benefit? What am I going to gain out of it? There are a lot of potential benefits from AI, so there's a very clear answer. There's a very broad area of application. Generally speaking, what we can accomplish through AI is basically automate things. Instead of having manual and labor work from a human, we can do a consistent and efficient work carried out by an AI model. And this can not only be a sort of a typical mechanical work, but it can also be something that resembles human interaction and human activity, what we call in other terms a cognitive ability. So in general, the application of AI and ML comes when we want to solve practical problems, including automating decision making, making predictions and making forecasting, doing forecasting, as well as when we want to automate the generation of content and the content analysis. By content, we mean any kind of documents, text, images, video, or audio. And at that point, I want to mention the generative AI area, which is very catchy, a very catchy term nowadays, and it's a very hot term being spoken about very widely in various communities, because everybody knows ChatGPT, which is one of the most well-known models globally. And it's basically a model, an AI model, which is able to generate authentic, genuine content based on a series of questions which are called prompts. So we enter prompts to the model as input, and the model is able to basically create authentic content based on our interaction and our prompts. And also, I would like to mention a few more areas, major application areas for AI models. These can be categorized in the commercial, governmental, and public interest and research fields. So further ahead, just a very quick glance without getting into the details. You can see the slide. I don't want to mention each and every one of them. I'm sure you will identify with at least one of them, either that being in a commercial setting, or if you have any association with a governmental body, and obviously the research and public interest areas. These are all global problems. Most of them are partially or entirely unsolved. And there's a very good chance that by using AI instead of conventional algorithms, we get very closer to tackling them in a more efficient way than we have used to before the emergence of AI. Just to give you a quick glimpse, alongside that, I have a few links. Let me just bring them up on my screen and share them with you on the in the chat window. Just bear with me for a moment. So I have 3 links that I have picked from the thousands of available AI services this moment. You know, 2 of them are just some very important, I think, distinct examples of AI applications. Let me share these with you in the chat window. Let me find the chat window first. Okay. So the first 2, as I mentioned, are 2 distinct examples of very high profile applications of AI models at the moment, very hot stuff. The first one being Google DeepMind AlphaFold model. And maybe some of you have heard of it, some others may not. It's basically an AI model which is able to predict and unfold, hence its name, the structure of each and every human protein known to date. So that means that continuing research, because that's not something that just stops, it's an evolving matter. Going forward, this is a very strong tool that the bioinformatics and more generally speaking, scientific community will be utilizing in the battle against cancer and many other diseases. The other principal example relates to autonomous flights and warfare systems. That's another very recent news which came out. As a matter of fact, it's May 2024. It was the first ever fully automated flight of a battle aircraft of the US aircraft, in which they had a very well-trained pilot who was basically overlooking the overall procedure. He didn't touch the controls, and there was an actual battle simulation between a human-managed aircraft and an AI-managed aircraft, in which the AI managed aircraft with its pilot didn't have to actually engage the pilot to make any corrections whatsoever, as if he was not there. Just imagine the whole thing. Autonomous flights is just one area. You can also think about autonomous driving, etc. Last but not least, I'm also giving you a link that's one of the many, which is what is called a directory, an AI directory, where you can see, where you can search by application area and find the tool that suits you best and has a lot of critiques and analysis from actual end users that will give you any hint on any kind of application area you might have imagined regarding AI. You can find this information in there's an AI for that.com. So I hope that this has given you a very good introduction into where we're headed right now, because we're going to get more practical and more technical, and I'm going to be providing you with a demo that has been prepared based on Certnexus material for the CAIP course. That's a very real demo, because it's not strictly confined to the course that we will be teaching soon enough, but it is related to the actual incident of the Titanic very many years ago. So the case study that we're discussing right now is, suppose that we're a university class and we're teaching history. We want to not just touch upon the surface of the event, we want to make it a little bit more interactive with the class. So suppose you're that class and you want to learn more about the why and how of the Titanic incident, why that happened, and what were the implications and which factors contributed to the people on board Titanic perish or not. It's a very interesting question where AI can come in and do the association and analysis of the data and lead us to making conclusions by extracting probabilities of why each passenger would survive or not. So how does that work from a technical perspective? First of all, we need to have a computing system where to train and run our AI-ML model. This, in my case, is a virtual machine, a Linux virtual machine running the Debian operating system, which I have on my machine and I will share with you shortly. On that machine, I have installed the Python language interpreter, which is the operating environment, the runtime, which is required in order to interpret the commands that we will run in the Python programming language to make all this magic happen. And at the same time, we do have the Jupyter Notebook runtime, which is a runtime comprising notebooks that can have either Markdown language. Markdown is a special notation language for writing text. Just think of Marktime as the language which is powering Microsoft Learn, if anybody knows Microsoft Learn, or GitHub, for example. This is the language that's actually used by these large websites to create all the content that they have in terms of text. And aside Markdown, we do have pieces of code in Python combined with Markdown inside the same notebook. So essentially, we have a notebook in which we have notes and code, and we combine them together to run the test, to run the specific lab exercise, train our model, and then get the result, which is to predict which passengers would survive the Titanic and which not. What we're doing is we're training a machine learning model, which is called the classification model. It is called classification because what we're doing is we're classifying the passengers into two major categories, either survived or not survived. So that's why we have what is called a label. You can see here on my slide that the label in our case is whether or not the passenger survived. What is a label? A label is one of the features, i.e. one of the columns in our data set, which basically signifies whether the specific row, the specific passenger, survived or not. And we will, when we split the data, we will take this label, this column outside, so that we can have a probability on this specific feature, on this specific label, to understand what the probability would be for any customer given specific factors, whether or not they would die. So the first thing before we move on is to understand our data. As I mentioned, we gather the data into files, large files that are called datasets. This is just an example, and do not expect it obviously to be an absolutely realistic one, even though the names are real and the list is real, because this data has been taken from the official authorities in the UK, I think, which actually hold the data of the passengers of the Titanic. However, in real life, we're not going to be talking about hundreds of rows. We're going to be talking about thousands or even millions of them. Anyhow, you can use this link to get into the Kaggle community. And if anybody of you is already in the ML or AI field or is eager to dive deeper into it, it is a very good suggestion that you create an account, a free account in this community. Is one of the many, one of the most prestigious ones for AI and ML professionals, in which a lot of data sets about many aspects and many areas are gathered, many analyses are run. There's a very vibrant community, and there are also contests running throughout the year for people who will manage to make ML models run as efficiently as possible. So the Kaggle community does have, if you open this link, you'll see that it does have the official full data set of the Titanic, which is basically a list of CSV files that include the names of the passengers on board and all the information related to them, such as which class they traveled at, what was the cost of their fare, their ticket, what was their ticket ID, if they had a spouse, if they had siblings, if they have parents, how many kids they had if they were married, what was their age, of course, and their sex, if they were male or female. All this information is gathered together in this data set and then is being analyzed from the CSV file to train our model and then be able to make predictions. So what we will do is we will continue by opening the Jupyter notebook file, which is an IPyNB extension file, which includes all the Python code and all the Markdown organized into sections, and then we will feed this with the CSV files which actually hold the data. Something important to mention here is that we actually do have two CSV files. One CSV file is for the training of our model. So we will feed our model with the training data so that our model makes the associations and gets the knowledge. And then once that's completed, we will feed, excuse me, we will feed our model with a yet expanded, a second file, CSV file, which is called the new data set. So the first one is the train test data set. Second one is the new data set. What's the difference between the two? The first one includes the actual passenger data from the Titanic that we want the model to be made aware of. Part of this, of the records inside the CSV, are going to be actually used for the training, and then the remaining ones are going to be used by the model to make predictions and compare side by side if these predictions are correct by comparing the prediction of the model with the actual label, which is whether the customer survived or not. All of these actions are going to be run from within the same CSV file, the train test, because all of them pertain to real customer values, sorry, real passenger values. And then when all this is finished, I will ask some of you to give me some real names and some data, hypothetical, let's say, if you were to be passengers of Titanic, so that we can see what the model tells us about each and everybody of these fictitious passengers, whether or not they would survive the Titanic. Before diving in, I will also give you an overview of what we're going to do, and it will all make more sense when we actually get into action. So at the high level, what we will do is we will load the Python data sets and libraries. We'll get acquainted with our data set and see what it actually includes. We'll get some statistical values that will help us understand the statistics of our data and use some plots like stacked bars to understand associations between age, sex, fare price, embarkation point, etc. Various factors that could have contributed to a small or large degree to the actual survival of the passengers. Then we will do what is called the data preparation and the feature engineering that we mentioned, if you remember, in the theoretical part, that is prepare our data to make them fit for our model. And then we will feed the data into the model to train it. And when the model is trained, and after it has tested and verified its predictions to the real data, we'll feed it yet with another file, which is the file of our fictitious data, to see how well it would make predictions in a real production environment. So end to end, that's the workflow that we will follow in the practice lab that I have prepared. So let me move on to show you. I'll stop sharing this slide screen and move on to my lab environment. Okay, so as I have mentioned, I have put on a Debian Linux machine. Please confirm that you can all see my screen. Okay, let me check. Okay, can I get some thumbs up if you can see my screen from the Linux virtual machine? Okay, thank you. So, first of all, let's quickly get acquainted with our datasets. Our datasets fall under the logistic regression. That's the type of algorithm that we're using for the classification solution that we're running. So we do have the I, Pi, and B, as you can see here. That's the file that I'm going to open and train the model on. This is the file that includes the Python code. And I also have the Titanic data folder here. I have the Titanic train data. This includes our actual passenger data. And I also have the test Titanic new data, which is the test that we're going to do later on the very end to verify in fictitious data if we have good predictions or not. And then I have a read-only file that I want to open up right now so that I can very quickly show you, get a look and feel of what the actual data set is, the CSV file. What are we feeding our model with? This is what we have. So we have approximately 900 rows, records, with real passengers from the Titanic. It's about 900 rows, and we have a list of columns, also called features. One feature is called passenger ID. The other one is called survived. This is a special feature which is called the label, and this is going to be differentiated from the others by splitting the data set into a separate vector that we're going to be using for the predictions. All the other columns, i.e. features, are the P class. That's the class where they're traveling on, whether that be first class, second class, third class on board. Then we have the name. That's the full name, and that's organized into a special manner. We'll make some preparation for that later on. Then we have the sex, we have age, we have another numerical value that summarizes the total number of siblings and spouse that the passenger may have, and the other one's the parents' children combined. Then we have a ticket number. Then we have a fare price. Then we have a cabin number. And then we have an embarked feature, which is the initial name of the city in which the customer has embarked on. And more specifically, these cities are C for Cherbourg, Q for Queenstown, and S for Southampton. So this is basically what we're fitting our model with. Let's close this, this file. So what we're going to do is we're going to start up our Jupyter notebook, double clicking on it. That will start a process that will load an HTTP session. So that's essentially our Jupyter notebook. That's the notebook environment. So what we want to get from here is we want to get the actual IP&B file that I mentioned earlier. So go logistic regression and we open the Titanic IP&B. So that's the actual notebook, which includes the Markdown code and the Python code that combines it all together to run everything that I explained previously at high level. So in practical terms, this is where all the joy happens. As you can see, this is a very large notebook and we have a lot of things to do. And we're not going to be covering every single detail right now due to the brevity of time. But I want you to understand the concepts and what actually is going on. So what we are going to be doing is, first of all, want to make sure that the Python, the Python kernel, which runs with Jupyter, is initialized, restarted, and cleared out, so that we start from scratch. And as you can see, our Jupyter notebook is organized into sections by using this markup language here. And each section signifies what exactly the code beneath it does. So the first part is import software libraries and load the data set. That's what the code does. We're going to be importing a list of Python libraries that do different things, manipulating numbers, sketching plots, etc. One of the most important ones here is the sklearn library, which is what is performing feature engineering and machine learning. So essentially, the model that we're running the classification with, the logistic regression, is powered by this single Python sklearn library. You'll see that later on. So what this first section does is it does the import of these software libraries, then it prints out which versions we have of the software library, and then it prints out as well what CSV files we have available. And for the specific Titanic train data CSV file, this is what we're fitting in our model with. It will report how many records we have inside that file. So let me run this first cell. Takes a few seconds. And as you can see, it interactively here, I get the output of this code, which is, this is the list of Python libraries alongside their versions, the data files that are included in this specific folder, as well as the number of loaded records from the Titanic train data CSV file. That's the one that we're interested in. Then we're moving forward with the next section. What we're doing here is we want to make ourselves acquainted with the data set. That is, understand some basic information about the rows and the columns, and just provide the sample information of the first 10 records from the data set. This is what these two commands do. So as you can see here, you see all the features that we have. That's the passenger ID, survived, P class, name, sex, everything that we saw previously in the CSV file. And for each of them, we can see how many non-null values we have. So for passenger ID, we have 891. This is the total number of records that we have. So that means that every record has this passenger ID value populated, no issues here. But some of the features you can see have less than 891 non-null values. So that means that for age, we only have 714 rows that actually have age populated for that passenger. Same happens for other properties like cabin, which we only have 204. Going down in our analysis, you'll see, and one good practice in certain scenarios is that if we have a lot of values missing, which are more than 50% of the overall values, then we might want to decide to discard that specific property entirely, as we will eventually do with the cabin property, cabin feature. And also in the D type, we can see the type of data that we have, either that be an integer or that be a float, decimal number, or that be an object, which practically here it means a string. So we'll have to convert at least the non-numerical numerical values, the objects, convert them into numerical so that they work properly with our ML model. And then below that, we see the first 10 rows from our real data set. And as you can see, observe that we do have the survived label. So we do know for each and everybody of them whether they survived or not. This is a definitive value that we feed the model with. And then the model does the testing and comparison. We'll see that later on. Before we move, we need to get some descriptive statistics. So if we run this cell here, we get the descriptive statistics of our data set. That summarizes from a statistical point of view how our dataset features stand. The most important statistical metrics that are output by this method here, the df_describe method, are the count, mean, standard deviation, minimum, maximum, and the percentiles. So count is the total count of the rows for that feature. Mean is the average value. Standard deviation is a metric that shows how far away from the mean value are the values of our feature. So this has to do with the distribution of the values. Then we get the minimum value and the maximum value. For example, let's say, for example, age, we get the information that the younger passenger was an infant, younger than 1 year old, and then the oldest passenger was an 80-year-old man or woman. And also the percentiles are the percentages which actually are the percentages to which this specific designated value sums up with. So for example, 75% percentile, if that has a value of 38, that means that 75% of the people in this distribution are up to 38 years old. Then if we continue to do some plotting, we will start to think better as to what the correlations are between our features and how these can affect whether the customer survived or not. This is something we have to do to understand our data better, because at the end of the day, this is what the model does. We don't have a certain formula here. We don't have a linear formula to say y equals a times x plus b, for example. It's not well defined. It's not a linear equation. It's something that we'll have to extract, something definitely non-linear and very complex that we'll have to extract from the data and be able to understand at large scale how that model works. If we run this cell here, we get a stacked bar to show survival numbers organized by feature. Let me try to make it a little bit larger for you to see better. So we get survival rates by color. So in the first plot, we get survival rates by class. The blue color is first class. The yellow color is the second class, and the green color is the third class. On the left, we have a 0, which means people which perished. On the right, we have people who survived, which is a number of 1. Survived equals 1. Also, we can see the same type of stack as organized and grouped by sex. The blue signifies the females and the yellow the males. Then we go for siblings and spouse, as well as parents, children, as well as embarked. I'll just make a very quick observation here. Is, for example, that we can clearly see that from the people who did not make it, the majority of them were in the 3rd class. So we start to make annotations, we start to make connotations about how these features are related. Obviously, the people who were not in the upper classes were not given priority during the rescue process. So that makes sense. Also, with regards to sex, I have read, and that's verified, that during the rescue process, the policy of the ship said that females had priority. So that's clearly shown here in the charts, because from the people who perished, the vast majority of them were male, and from the people who survived, the majority of them were female. So we can go on and make more connotations like this, but you get the point. Now, the next step is to try to find relationships between survival, age, and sex. Let's run this section here and see a similar graph. So we have 2 graphs. One graph is the female survival by age, and the other is the male survival by age. By the way, think about how much time it would take you to manually make these annotations and these presentations and these plots yourself, unless you were using a language like Python and a special library that can automate all this information and present it in a very clear fashion. So we can see that both the female and the male survival organized by age, we get higher chances of surviving. Survival is designated by the yellow color. We get higher chances of surviving for people who are younger, generally speaking. And then the distributions differ a little bit between females and males. It's clearer for females because most females actually survived. But again, the people who are elderly, the vast majority of them did not make it. And that again makes sense because from a mobility point of view, they were not as competent as the others. So everything here makes sense. Now, we do need to make some more preparations about the data, and we need to make decisions about how to handle the value of tickets, the personal titles, the embarked port codes, and prepare our data set so that it's ready to feed in our algorithm. So what we're going to be doing after running these cells here, first of all, we're listing all the tickets. These are all the numbers of tickets organized alphabetically. Then we identify by doing some calculations and some manipulation on the data set. We're isolating all the types of personal titles and the embarked port codes. And as a matter of fact, we do get these different types of titles for different people inside our 900 rows in the data set, as well as we have these different types of embarked locations. None stands for not a number, so it's basically a null number, it's empty. So what we're doing in the preparation of the data set is we're basically filling in missing values for the ones that are missing by using either the mean value or using the mode. The mode is basically the majority, the value which has the majority among the rows. So essentially at high level, what this code does here is that it's actually filling in any missing values, and then it's doing feature engineering. So that's extracting information that is going to be useful for training the model so that the data is actually proper for being fed into the model. These types of activities include determining the size of the family for a passenger, also extracting the title from a passenger name, replacing titles in the top 4 with a special title. And what we're actually doing here is we're doing what we call a hot encoding. So instead of having sex, for example, being male or female, what we do is we transform this into two additional columns, which are called is male or is female, and these in turn take a value of 0 or 1. It's like a Boolean value, a logical value. So instead of having sex male and female, we feed the model not with the information male or female, but we feed it with information 0 or 1, depending on whether or not they're a man or a woman. Similar with the title and embarked. So let's run also this part of the code here to prepare the data set. What this gives us as output is it's telling us what's happening before the preparation in terms of how many null values we have. So in here you can see we have 177 for age and then 687 for cabin, etc. And after the preparation, all these are zeroed because we have filled in the necessary information, except for cabin, because later on we decide that cabin is going to be totally dropped because it doesn't offer any extra information for the prediction of who survived and who didn't. So if we preview the current data now, we see there has been some sort of a transformation here. Instead of having, for example, the embarked name of the city, whether that be C, S, or Q for the name of the city where they embarked from, we created additional columns called embarked S, embarked C, embarked Q, and then each row, each passenger will have a value of 1 allocated to the port from which they embarked. So these are the kinds of things that we do as part of feature engineering. And then depending on the analysis of the data and the associations that we see, we might need to drop some columns. We decide at this point that we will drop passenger ID, cabin ticket, and name, because these do not offer any additional value to our model. So we'll do the dropping, and the code is outputting that these are the columns before the drop, these are the columns after the drop, and then we get another head. Okay, so this is probably a bug that is related to what is has run previously. No, sorry, I have tried to run the same piece of code twice. That's why it happened. So if I try to run this now, I get the new states of the data after this preparation. And I'm getting just a sample, getting the first 5 of them. So now we're at a very critical point. We have prepared our data and we need to feed the data into the model. But before we feed the data, we have to split them. What does splitting mean? We have to split the data into 2 big groups. One group is the train group and the other group is the test group. But before we even do that, we will have to make sure that the label, which is the feature called survived with a number with a value 0, 1, is split on its own in a separate vector. And then for all the other about 900 rows that we have, we split them into 2 groups, which are, as I mentioned, the train group and the test group. As you can see here, we basically, besides the survived, which is special label column, we get an X train and a Y train. And also we get an X test and a Y test. What that means is that for all 900 rows, we split them by using a certain method. And by using this method, we split them into 2 static groups. One group holds the number of rows that will be used for training, and the remaining ones, which are less than the training rows, are going to be used for testing that will be performed by the model to compare its own predictions based on the actual values of the survived label that exists in the real dataset. So we do get an X train and Y train and an X test and Y test. Let's run this. As you can see here, the 891 rows are basically split into 668 for training, and 223 for testing. And we also split the 17 features into 16 features for testing and training, and also into 1 feature for testing and training, which is basically the label. So out of all our features, 1 is the important one because 1 is what our whole classification is based on. So with this information, we're now at the most critical point. This is where exactly right now we're going to be running the training of our model. The model will take these training features as input, and it will learn from them. And then it will do its own testing and see how well it performs by trying to predict the survived label for each and every one of the 223 test data and compare its own prediction to the real value of the survived label. Based on that testing, it will output its own accuracy and tell us, hey, I'm good at 85% or 90%. Anything above 80% would be regarded a good value given the simplicity of this example. Because in real life, what we would do is we would take a lot more steps which go beyond the scope of this webinar that would even make the model more precise. So at this point, we run a specific logistic regression method, which is the algorithm that takes some additional parameters and runs a lot of iterations to make the training. So we get a start time and end time, and then we run the fit method, which actually does the training. So if we run this, it'll take a couple of seconds, a few seconds. It's very, very fast, as you can see. It actually took milliseconds to fit the model. The score on the test set is 83%. It's not bad, as I said, given the circumstances. And then we use the test set to do the evaluation. This will visualize the evaluation of the model. As you can see here, we have two new columns. Basically, these are created by this code here. So we call the predict method. The model is doing its own prediction on the test data, and it's actually outputting the probability to either perish or not perish. And this is shown in these additional columns here. So we can see that for each row, for each passenger, we do get a predicted survival and an actual survival. How well did our model do? If you can compare optically, you can see that most of the values are correct, and the model falls out, is incorrect only for one row, the first one here. It also gives the probability perished and probability survived. So now that we have reached the end of our discussion, what we want to do is we have trained the model, we have run the test. We want now to get at the point where the model is deployed into production, into a real system, and we feed the model with unknown data that the model has not seen before. And it has to make decisions based on what it has learned during the training. So for that reason, we have the test Titanic new data CSV file, which I opened later on. And at this point, I would like to ask if anyone would like to unmute themselves and be a volunteer so that they can provide their information just for the sake of this demo, without any personally identifiable information, just for the sake of this demo, to see how the model will respond to the data that we provide. Would anyone like to volunteer? Let me see if we have something. Okay, we have Andreas, I can see. There are a lot of names. I barely managed to see Andreas. If there's a single Andreas in the webinar, please unmute yourself and let's work together to fill in this value. I'm not sure if it's possible actually to unmute yourself. That's a good question. Kali, can we do that for any of the participants, or is it blocked by policy?
No, they can unmute.
Okay.
Oh, Andres Kyprianou says that they have a trouble with, he has a trouble with his Microsoft.
Oh, okay, no worries.
Microsoft. Oh.
No worries. Well, it's not that fancy. You get the point. It's just I want to make you more enthusiastic about it because you're getting very close to a real life problem, and you see what technicalities must be taken care of in the background to make this happen, to make this actually work in a real setting of a real AI-ML system. So I'll just go ahead and provide my own details. That's not an issue. If I open this file, and we will end with that. Let me open the file. I have it right here. It's the test Titanic new data. So I'll just rephrase that and provide my surname and first name. So if I start, let's say, with a real age, and then I provide some more or less real information, let's see how well that can go. By the way, I embarked from Southampton. I lived in Southampton, and I'm more related to that place. So let me save that. And what I'll do is I'll come back and inside the Jupyter notebook, and what I'll do is I will run this. Okay, let me just make sure that it just loads the data right now. Yes, okay. So what it does, it's just creates the path, and then it uses this method to read the data from the CSV, which is basically this file here, the file that I just edited. So if I run this cell here, it just reads that I loaded all 418 records from this test Titanic new data, and then I'm going to do the preparation. Okay, so it's giving us a summary of what's going on regarding preparation of the data. Again, it's some sort of a normalization, very similar. It's the exact same thing that we did previously. And then I'm going to be giving you the predictions exactly the way I did before. So I'm getting the predictions here for myself. Unfortunately, I died. And I get the probability for perishing here versus probability of surviving. Now, an interesting thing here is, and something like an open question to you to think about, is which feature from what you have seen up to this point, and also based on common sense, would you regard as the most influential for the survival probability to increase or not? I would like to see some answers on this question, just to get a feeling of what you think about it. And then we'll do a couple of tests to verify whether or not that's true. Does anybody want to speak up and say their opinion? Yes, being female is a good one. And as I can see from Mariana, unfortunately, you're not. But that's a very good observation, because it's clear that if you were a female on the Titanic, chances were that you would survive, especially if you were in a higher class. So if you were a female in a first class, you would have great chances of surviving. Even if you've watched the movie Titanic, you would see that, you know, all the life boats that were used, they were prioritized for women from first class. So that's actually true. Any other hints, any other suggestions? What other factors besides the sex might have contributed? It was an interesting one for me as well. I did a lot of trial and error to see the contribution in practical terms. And now unfortunately, we don't have the time to do all of that, but I'll get to the bottom of it, is that after trying a lot of trial and error, I realized that, believe it or not, one of the most important properties, features that influences in probabilistic terms, influences the survival, is the price of the ticket, is the ticket fare. So the higher the fare, the more the chances that you survive. And that's, it's not directly, it's indirectly related to the fact that the higher the fare, the better the conditions that you were in, and the higher the class, of course, that you were in. And even in the first class, you had different compartments. So it was not just first class, it was first class, high fare, first class, medium fare, first class, low fare. So the people that had the highest fares, which were top of the line, and they were the VIPs, they had the absolute highest probabilities of surviving. If I do that, for example, for myself, just to verify and see, just keep in mind what my probability for survival is. It's 21%. If I change the file, And instead of having a fare of 100, which, by the way, already is high enough as compared to other ones, as you can see, some people spend 10, for example, 10 sterlings. I think it's sterlings. If I go for 500, for example, let's just make this change only and see how that affects our probability, which was 21%, if you remember. So now my fare goes very high up to 500, almost close to the top of the overall cost. What I'll do now is I'll go back here and I will instruct the kernel to restart and clear output because I want to do recalculation of all things. And when that's done, I come here again, I click on this markdown cell and I instruct it to run all the above cells, except for the one that I'm in right now. So it runs all the iterations, everything we've done up to this point very quickly, goes all the way down to having a fully trained model, and then I'm ready to rerun this iteration with a changed CSV file. Now, my fair price is 500. Let's see what we get. What is the probability now? Believe it or not, it's 96%. That sounds very surprising. If I were to give you a different trial and error playing around with another type of feature, it would be totally different. So for example, if I went from first class to second class, that probability change would not be that significant. And obviously it's not one size fits all. Every model is unique, every situation is unique, every data set is unique. So if that same model was trained on different data set, a larger data set or a different data set, or if it was trained by a different algorithm, it would have been different. And in real cases, in real life scenarios, what we actually do is we do a lot more data preparation. We follow different and more sophisticated methods for splitting the data. And we also apply more than two algorithms and then compare the outputs to identify the proper algorithm for the specific case. All this discussion is just for you to get a first very high level view of what's going on and why there are a lot of factors, why we need to consider all of these factors when making decisions about what algorithm we're finally going to be utilizing in our problem-solving scenario in artificial intelligence. I hope this clarifies things for you, at least at this high level. So that's the end of the demo. Let's go back and say a few things about the certification, and then I think we should be done in no more than 5 minutes. Let me reshare my screen with the slides. And please give me another thumbs up for being able to view the slides. Thank you. Last but not least, we answered the why. That's what I always like to do when I teach. First, I want to answer the why. Why would I even bother spend time on this? I think we answered this question sufficiently. Then we answered the how. Obviously, we cannot fit in all the knowledge about AI and ML in 1 hour, in a 1 hour's webinar, but we did approach the how. And this approach is very close to real life. Now, after we have answered the why and the how, the final question is what's next? And how do I make all this knowledge, how do I transform all this knowledge into practical skills, practical abilities that can equip me as a person or as a professional into solving problems and into progressing with my career? The answer to this question is certification. There are various AI certifications out there in the market. Some of them are vendor specific. That means that they are organized, presented, and maintained by a specific AI software hardware vendor, that being, for example, Google or IBM or Microsoft, just to name a few examples. Or it could be a certification that is vendor agnostic. That means it equips you with all the proper knowledge to understand concepts, understand procedures, understand the practical point of view and the operational side of things from a technical and professional perspective without, however, tying you to a specific set of technologies. Obviously, knowing Python is an important prerequisite because Python is the leading language in AI and ML. It's not the only one, however. There are many more. So this is where the Certnexus certification comes in. It's a vendor neutral organization. It's covering a lot of materials and a lot of areas and topics. In the scope of our discussion, we're talking about the CAIP, Certified AI Professional 210. This is a course that New Horizons will be running very soon. It will be starting out very soon and will be running throughout June 2024. And this whole preparation, this whole course, which is going to be highly hands-on course, combining theory with practice, is going to lead all participants to taking the Certnexus CAIP-210 certification exam, which is definitely very attractive to employers. It's a huge leap in your either existing or new AR/ML career, and it definitely equips you with hands-on knowledge to be able to think in AI and be productive in the emerging era of artificial intelligence. You can find more information about the exam and the course if you're interested in this link. Let me see if I can copy this for you. And just to give you also information about the question I saw regarding the code, no, unfortunately, we cannot make the code available to you separately, but you will be getting the video recording so you can review everything that has been covered up to this point. And at this point, I conclude everything I wanted to show you. Thank you very much for your patience and attendance. Hopefully that added a few things, new knowledge.
Thank you.
And I'm open to questions. So if anybody would like to ask anything specifically.
Can you hear me, guys?
Yes, we can.
Oh, sorry.
I
Yeah,
hear you.
thank you. Just about the module, the training method, the linear regression. I know there are more. Is there any preference over which one to use for a particular case set of data, or is just more like trial of them and check which one gives you the best results?
There are some general rules that we apply. For example, by the way, this was not a linear regression. It was a logistic regression. A linear regression refers to a model that actually helps us to predict a continuous value. Like, for example, I want to predict the temperature within the next month. So weather forecasting definitely can work with a linear regression, for example. So there are some general guidelines. What types of problems do we tackle with regression algorithms? What other types of problems can we tackle, for example, with clustering? You need to understand the theory unless you already know it. We organize problems into what is called supervised learning, unsupervised learning, and semi-supervised learning. So depending on the type of problem, we have categories of algorithms that can apply to it. So we start from that classification, we classify the problem, we understand what type of problem it is. So we have a list of potential available algorithm families. And then what we do in practical terms, we try at least two of these families for that specific problem area. And given on the feedback that we get from the metrics, we make the final decision to use one over the other.
Okay, makes sense. A lot to learn there. Thank you.
Yep. We have a question from Mariana. I think I see a hand raised.
Yes, hello. My question is a little bit, I don't know, tricky, I think. We saw that you trained the model for one time only.
Mm-hmm.
Question is, if we train it multiple times, is that a way to achieve better, how can I say, better accuracy for our model?
Definitely. That's a very good question.
Okay, how many times is enough? You know, from after one point, I think that the results will start deviating again and deteriorating. So how much is enough?
Very good question. The answer I would give you is attend the course. You will get a very detailed answer in the course. To give you a very quick answer to that is we have two parameters what are called bias and variance. And we also get two terms that are called overfitting and underfitting. So when we train a model, we also call it we fit the model with data. What happens sometimes is that if we overly do it and we go beyond a certain point, as you very well mentioned, then the model will be very tightly capturing information about this specific data set that we have and will not be able to generalize well when it sees unforeseen unknown data. This is a situation which in ML is called overfitting. In order to be able to battle overfitting, what we do is we follow more specialized methods in splitting our data. So what we saw in our demo is called the holdout method, which is a static method and is not very advanced. In real life systems, we usually tend to make use of what is called cross-validation methods, which basically do a dynamic split of the data, not in a static way, but in a dynamic way. So that means creating unevenly sized groups of data from the training data set and using different parts of them to be training data and then others being test and then swapping between the two and doing that multiple times so that we can achieve what is called the sweet spot. The sweet spot is the best compromise between underfitting and overfitting. So it sort of signifies the ideal number of iterations, if I can call it, if I can refer to it simplistically, the ideal number of iterations that we should train our model on to get the sweet spot and be able to have the highest possible efficiency.
Thank you very much.
You're welcome. Another question from Haris Severpidou.
Yes, hello.
Hello.
I also typed the question in the chat.
Okay.
So my question is if we can differentiate between what is just plain statistics calculated by computer and AI or machine learning.
Mm-hmm.
So as I understand, unless we go into deep learning and using something like neural networks, this is just statistics calculated by a computer, or it's not just the same?
Yes, it's definitely just to make it clear to your mind, statistics is not a field which is outside of the field of ML. If you remember in my Venn diagram slide, I show you that we have data science. So data science includes probability theory and statistics theory. So statistics is a major part of machine learning because it is an area which contributes to the methods of machine learning. So what you saw during these calculations and these median metrics and standard deviations, etc., are integral parts of ML. So you should not differentiate one from the other. The answer is that you use statistics to train the machine learning models. It's part of the data preparation process.
Okay, clear. Thank you.
Hopefully that answers the question.
Yes, thank you.
Any other question?
Any more question? Anything that you would like to ask before the session is closed?
Okay, I think we're over our time anyway. I hope this was entertaining enough and offered something new to you. And hoping to see you in the upcoming course for any of you who is interested in getting deeper into all this information.
Well, thank you everyone for participating. If you have questions or if you need anything, feel free to send me an email. If any one of you would like to have a certificate of attendance, send me an email and I'm going to send one to you. Once again, Thank you all for coming. I am going to send you the recording of this session in the next couple of days, and have a lovely evening. Bye.
Thank you very much. Thank you all.
Thank you.
Thank you. Bye bye.
Bye.
Thank you.